Okay, so let me just check these off. Let's check these off. We've done 1, we've done 4, 6, and 7. So 8 says, if the base of a right isosceles triangle is 4 inches, how long are the sides? So we talked about this one. A right isosceles triangle means that the legs are the same, and in our case it tells us that the legs are 4 inches each. Since it is a right triangle, it means we can use the Pythagorean theorem to find the third length. Okay, so we're going to use Pythagorean again. 4 squared plus 4 squared equals c squared. 16 plus 16 equals c squared. 32 equals c squared. In order to solve this, we are going to take the square root of both sides. Square root of 32 equals c. Now, obviously I don't want that answer. We want to look for the greatest common, or the greatest perfect square that goes into 32, which in this case is square root of 16 times 2 equals c. The square root of 16 is 4, so 4 radical 2 is c. And this is my correct answer, and it fits with the pattern for right isosceles triangles. It's leg, leg, and then leg square root of 2. Okay? On to number 9. Number 9 says, how long is the altitude of an equilateral triangle with sides of 6 feet? So, equilateral triangle means that all of the sides are the same length, and in this case they are all 6. We want to find the altitude, which is the length of this side that goes down the center. Now I know that this altitude here bisects the base and it bisects the angle at the top. So we've got a couple of things here. I'm going to redraw this, and we're only looking at this part of the triangle. Okay, we know that this is 6. We know that since this altitude bisects this, it means that it's half and half. So that's going to be 3 over here. This is my unknown quantity. Okay? Now, because this is, again, a right triangle, we can use the Pythagorean theorem that we used a second ago. So we're going to say, let's call this x. Okay? X squared plus 3 squared equals 6 squared. The c is always your hypotenuse. Even if it's a number that you already know, it's always going to be your hypotenuse. So here, I get x squared plus 9 equals 36. Then, to get x by itself, I'm going to subtract 9 from both sides, which gives me x squared equals 27. Take the square root of each side, and I get x equals square root of 27. Now, you again know by now that this is not a satisfactory answer unless this cannot be simplified, but 27 is the square root of 9 times 3. And that 9 has a perfect square root, which means that x equals 3, the square root of 3, which fits the pattern for 30, 60, 90 triangles, which this one is. Okay? So there's the answer to number 9. Number 10 says, do the points 0, 0, 5, 3, 5, 7, and 0, 3, when joined in succession, form a parallelogram? The easiest way to do that one, I'll push this up to the top, is to use our handy dandy graph paper. So we're on number 13. We're going to graph these 4 points. 0, 0, 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. And it says in succession, which means we're going to join them in the order they show up. 5, 7. It's 5, 1, 2, 3, 4, 5, 6, 7. And then 0, 0. Oh no, 0, 3. 0, 3, 1, 2, 3. Okay, so does that create a parallelogram? It's close. It's definitely close. We have to look at the rules for parallelogram, which means that it has 2 parallel sides and 2 pairs of sides of equal distance. The easiest one to do in this case is to find out if the sides are parallel. Well, these 2 sides, the vertical ones, obviously are. Okay, because they're both vertical. The other things we can do, though, are check these 2. So if we do rise over run for these 2 sides, this one goes up 3, 1, 2, 3, and over 1, 2, 3, 4, 5. So the slope for this line is going to be 3 over 5. If the slope for this other line is the same, then we would need to check the distances. Let's go ahead and see. So this one, we're going to go up and over. In this case, it's up 1, 2, 3, 4, over 1, 2, 3, 4, 5. So my slope for this line is 4/5. Since these two slopes are different, that means these lines are not parallel, and this cannot be a parallelogram. Okay, so that's number 13. Number 14 says, what is the measure of an angle formed by any diagonal in any side of a square? Well, let's go ahead and do that on this paper. So we're on number 14. It's talking about a square, so we have sides that are all equal length. And what we know about squares is that all of our angles are right angles. And we know that a diagonal goes from one side, one corner, to the opposite corner. And it wants to know what is the measure of any of those angles. Well, all of those angles are the same. But the way you do it is because we also know that these are going to be equal sides. Okay, that makes this an isosceles right triangle. Okay, so what that means is if I draw this as an isosceles right triangle, let's see what I can do here. So there's a right triangle. I know that this is 90 degrees. It says that it's isosceles, which means that not only are these two sides the same, but these two angles are also the same. So we'd use the same formula we used up here. So it's going to be 180 equals 90 plus x, x being this unknown angle. So it becomes 180 equals 90 plus 2x. 180, or sorry, we want to subtract 90. Got ahead of myself. 180 minus 90 is 90 equals 2x. We would divide both sides by 2. And we end up with x equals 45 degrees, which is my correct answer for number 14. Okay? Now, number 16. 16 asks, what is the radius and center of the circle x minus 2 squared plus y plus 4 squared equals 36? So I'm going to copy that whole thing down here because I know I'll forget it. So we're on 16. The equation is x minus 2 squared plus y plus 4 squared equals 36. And the formula we're going to use for this and the next question also is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. So that means I would need to find out what this is. It's going to be the opposite of the value on the inside, which is 2, opposite of this value, which is negative 4, and 36 equals r squared. So I would need to take the square root of both of those sides. And I end up with 6 equals r. Normally when you take the square root of a number, we put plus or minus, but the radius cannot be negative. So we're just going to leave it as is. So the radius is 6. And that is my complete answer for this one. When it's already in the equation, it's pretty easy. I'm going to pause for a second though, because the next one requires us to do a little bit more algebra. So hold on.